Hi, this is Dr. Ann O'Connor. Welcome to Pathways to Chemistry. We're going to continue with conversion factors and problem solving, and we're going to do some more complicated problem solving here. Now, this first problem states that an average drop of water is 1/20th of a milliliter. How many drops are in 3.7 liters? Well, the first thing that I like to do is write out my given, okay, which is 3.7 liters, and then my desired unit, which is going to be in drops. So now I'm given some information in the problem. I'm told that 1 drop is equal to about 1/20th of a milliliter. Okay. Let me go ahead and simplify this a little bit. I'm going to multiply both sides by 20, and that way I can cancel out that fractions. Let's see. We can say that 20 drops is equal to 1 milliliter. This gives me an equivalence. I'm going from liters to drops. Now, first thing that I'll need to do is, for my equivalence here, I know that 20 drops is 1 milliliter. So now I'm going to have to convert liters to milliliters. And then finally, I can go from milliliters to drops. So I need one more equivalence. This equivalence takes care of this part, okay? But now I need an equivalence that takes me from liters to milliliters. Well, we know that there are 1,000 milliliters in 1 liter. So now I have an equivalence for both arrows here. So I need 2 sets of conversion factors. So let me go ahead and write out each set. So 1,000 milliliters for 1 liter, or I can write it as 1 liter for 1,000 milliliters. So that takes care of the first conversion. Now we want to go now from milliliters to drops. Remember, this is my roadmap, and it's always a good idea to follow your roadmap as you go. So let me write out the second set of conversion factors, and I have 20 drops per milliliter, or I can write 1 milliliter per 20 drops. Okay, we're all set here. I have my 2 sets of conversion factors. I have what I need to set up this problem. So we're starting off with 3.7 liters. So 3.7 liters. And what I want to do is I want to get from liters to milliliters. In order to do that, I want to cancel out liters and be left with milliliters. So I will have to use this conversion factor here. So 1,000 milliliters per liter. My liters cancel out. If I were to stop the problem right here, okay, this would give me the number of milliliters. But the nice thing about conversion factors is this. As long as I keep canceling out units, I can string as many of them along as I need to. So all of your problems are going to be different, and it's all going to depend on the number and types of equivalences that you can remember. So now I'm at this part. I'm converting from milliliters to drops. So I want to cancel out milliliters and end up with drops. Again, I'm going to use this conversion factor here. So that's going to give me 20 drops per milliliter. Milliliters cancel out, and I end up with drops. So let's go ahead and calculate this. I have 3.7 times 1,000 times 20. And that's going to give me 74,000 drops. So let's get that in here. That gives me 74,000 drops. Now, I could leave the answer like this because it does have 2 significant figures, okay? So that's certainly not a problem. Or I could convert this to scientific notation. And if I did that, I'd move my decimal point 1, 2, 3, 4 places. I would have 7.4 times 10 to the 4th drops. Now, let's go on and do another problem. Here we're asked to convert 5.3 gallons to cubic centimeters. So we're given 5.3 gallons, and we want to convert that to cubic centimeters. So I have my given and my desired units. So let's see what I can do here. I need to get from gallons to cubic centimeters. Well, I need to get to the metric system. So I know that I can convert gallons to liters, okay? And let's see, I know that I can convert liters to milliliters, and we know that 1 milliliter is equal to 1 cubic centimeter. So I have my roadmap all set up here. I have 3 arrows, I need 3 equivalences, and 3 conversion factors. So the first one is easy. We have 3.78 liters equals 1 gallon. And let's see, from liters to milliliters, I know there are 1,000 milliliters in 1 liter. And then from milliliters to cubic centimeters, I know that 1 milliliter, 1 milliliter equals 1 cubic centimeter. So I have my 3 equivalences. Now all I need to do is write out my conversion factors. And again, when you're new to this, I would suggest writing out both sets of conversion factors until you get used to working these problems. So I'll write out my conversion factors for this one. Okay. And then finally, my conversion factors for this equivalence. 1 cubic centimeter over 1 milliliter. Okay, I'm all set to go then. So I'm going to start off with what I'm given. So I'm given my 5.3 gallons. And I want to use, so I'm at this part of the roadmap here. So I'm converting from gallons to liters. So I'm going to use one of these conversion factors. Again, I want to cancel out gallons to be left with liters. So in order to do that, I would use this conversion factor here, and my gallons cancel. Now, if I would have stopped the problem right here, I would be calculating the number of liters. But I'm going to continue on because I can just string these conversion factors together until I get my desired unit. I'm going from liters to milliliters, and I'm going to use one of these conversion factors. And again, I want to cancel out liters, so I'm going to use this one here. And so we have 1,000 milliliters per liter. So my liters cancel, and now I'm left in milliliters. If I were to stop the problem right here, I would end up with number of milliliters. But I'm going to continue on and do this last conversion. Here I'm going from milliliters to cubic centimeters, and I want to cancel out milliliters. So I'm going to use this one here. So 1 cubic centimeter is 1 milliliter. My milliliters cancel out, and I go ahead and do the calculation. I have 5.3 times 3.78 times 1,000 times, times 1. So I end up with 20,034 cubic centimeters. Okay, I'm going to go ahead and report this in scientific notation because I've only got the 2 sig figs here. So let's go ahead and do that. So that would be 1, 2, 3, 4. So that would be 2.0 times 10 to the 4 cubic centimeters.